let's do this. Yeah, I don't know directly which conversation I had that made me think this would be a good talk to put together and stir some discussion. But it's the one that came to mind this morning when I was preparing to give the talk was Ben, and I can never tell if he's doing so sarcastically or not. Whenever I describe, oh, I just want to use a function from another library as a Parsl app, he tells me, well, that's a novel use. I don't know if you're being serious or not, Ben, but regardless, it made me think, hey, I try to do this all the time, and that has potentially made me work in a way that is probably not described very well in the Parsl documentation. So, namely, that I don't use the decorators, basically ever. So I thought to give a talk to that today, stir some trouble, see what kind of discussions we could have around whether this is a good idea that we should move towards like mainlining in our like descriptions of how people could use Parsl, or whether it's a horrible thing that I should keep not doing. Or sorry, keep from telling people I do, because at this point I'm pretty confident in how I like to use Parsl, and I'm not saying I won't be dissuaded, but I will say that it'll take a couple rounds of Yadu and Ben and others convincing me of the light. With that said, let's go to kind of level set with what are these decorators I'm talking about, and how are they used in Parsl? Many of you might already see this, it's right on the README, but the way that we describe to use Parsl is to take an existing Python function, mark it with a decorator like Python app, which turns it into a Python function that can be executed remotely, concurrently with other functions, etc. And this is great and fantastic, but I rarely, if ever, do that. So what I thought to do today was talk through continue level setting. What are these decorators actually doing under the hood? Explain where they should be used, why I find them useful in many cases, and then expound on why I avoid them and how by avoiding these use of decorators, we can potentially expose some functionality in Parsl that many others will find useful. So with that said, let's go and talk through that first part. What is a decorator? So a decorator is not something that's specific to Parsl. A decorator is a programming syntax within Python where you mark a particular function with a label, which is another function that will replace your original one with some other functionality. For instance, the classic one could be caching the result. So this decorate label will check a cache and execute the inside function only if that input has not been is not available in the cache. You could do crazy things like altering the arguments to the call, perhaps changing X to an integer, regardless of what input format it is. Or in the case of Parsl, you can delay the execution of inside and replace the output of inside with a future that marks the execution of that function on a remote system. So in short, you can do a lot of very tricky things with these decorators, and Parsl does some pretty cool stuff. What it actually happens in the decorator is pretty straightforward. This is the decorator function here. And while there's a lot of arcane Python syntax that I don't think we want to talk about today, it works. We'll leave it at that. The core of what this function does is actually replace whatever function you passed it, here it's denoted f, with this Python app function that contains the information necessary to execute this function remotely, such as what is the data flow kernel? I don't know what a data flow kernel is, so that's about the extent of what I want to talk about it. Whether this is a cache function, which remote executors it's allowed to go on, and such. So here you note all this app does is replace your original function with a Python app. What does that app do? That app implements a call function that when you attempt to call it, submits your original function, here named func, to the data flow kernel, which manages its execution and provides a future to indicate whether that function has completed and give you access to results and such. So in short, what actually happens here between when you decorate that function is you capture that function and any of the information that's going to be used when executing it remotely, such as where can it go, stores it as a Python app, which can, when it invoked later, submits the function and any of that other kind of metadata you've captured to the data flow kernel and returns a future. So fairly straightforward. All these apps are doing is allowing you to express a function as something that can be executed remotely. But I don't actually do that. I don't use this function decorator very often, hence the title of my talk. And that's because my work gives me a lot of headache even before I get to the point of trying to run with Parsl. If I'm developing a Python function, I typically go through the typical iterative process of outline the full computation of what I want to do, break it into small enough chunks that I can write unit tests where I can write down what the answer to that longer function is supposed to be, compose them all together into the big execution, and then I start worrying about trying to execute that thing remotely. Because of course, there are going to be some issues that show up with Parsl just because running things on a remote HPC system requires moving it from your laptop. And I try to delay any of those questions until after I'm certain that what it is I'm implementing is rock solid. So there are a couple reasons besides that issues around why delay using that Parsl decorator. To be more specific, I don't want to have to run Parsl when I'm testing my functions. It slows down the testing process significantly. I don't want to have to debug simultaneously my science and the Parsl. And then I've got a few things that are more aesthetic. I don't like all the log files that it produces, and it locks me into Parsl immediately. I'm one of the Parsl developers, so I'm probably going to end up using Parsl just because of the workflow systems. I understand how it works the best, but I still don't like hard coding whenever I can't avoid it. So those are sort of my top 4 reasons. And besides those push factors, there's a lot of advantages that pull me towards decorating later. One that's kind of duplicative of things I've already said. I'm starting from a point after I've applied this conversion to an app that I'm starting from a good base, that I know any problems that I see are probably due to the fact that I'm starting to run this on a distributed environment. Another reason that causes me to wait to applying that Parsl decorator is a lot of those execution variables that are described, namely executor names, I may not know until I'm actually executing the process. I tend to reconfigure my Parsl configurations particularly often. So same library might be used with a number of different configuration operators. And additionally, the mechanisms that Parsl uses to serialize functions that are marked with decorators, I don't understand enough to trust them a lot. I know that if I create a Python function inside of a library, pickling it is particularly simple. If I say import one of the functions that I've written for a library I'm working on and pickle it, you'll see that it's basically just a reference to the location of that function. No code getting pickled, no cloud pickling or DIL specific functionality, just a little reference. This gives me a little bit more trust in being able to understand what's going on if I delay this pickling until later. So that's the short version. So what it ends up looking like in practice is one of these functions. So this is a application I wrote a couple months ago, uses Parsl to quickly evaluate the energies of many molecules. And here's the core bit. I've created a function run molecule. You can see it inside of a library here. When I actually start executing the application, this is my main function here, compute emin. I load in that function. I perhaps apply some wrapping to it to pin specific arguments. And at that point, you can see I'm calling the Python app decorator now. Maybe the fact that I'm calling it a decorator is a bit confusing. I'm calling the function which can be used as a decorator is a more precise way of saying it. But in short, I'm taking my existing function and only turning it into a Python app at the last moment until I actually need it before execution. And this is in contrast to ways that other folks might work with Parsl. And it's actually in contrast to ways that I tend to work for other projects, because decorators are really cool. If I'm doing something that's not code that I'm going to work on a long time, I still use it. Here's another example of your standard Python program. I'm not doing anything with changing names of executors ahead of time. Most of this is very straightforward code, so I'm not going to worry about debugging it or changing it very often. And in short, I don't need to do any good development practices, so I'll do things the way that Parsl's documentation tells me to. And if that statement worried you, it also worries me. I don't want Parsl's documentation to lead me down a path that makes my application testing any harder than it is. So this goes to the part where it's maybe a bit more speculative musing. And at this point, I've monologued for a while. Does anyone have any objections before we go to kind of a more forward-looking segment? All right. If not, I'll poke forward a little more. The thing that really kind of struck me as I was putting together these functions is a lot of what I described of my reasons for delaying functionality doesn't necessarily need to be. I can decorate a function. I can then, knowing the internals of Parsl, change some of those runtime parameters. For instance, if I know that I'm working with an app function, I can change the list of executors that is available to run on, call it, change it, call it again, and now I've got the same function without having to decorate it twice, running on two different execution environments. I don't do this because it's an undocumented feature, but if we kind of move towards realizing the kind of practical effect that the Python app function creates a separate object that contains information and abilities that are different than that original function, we can start to implement some more advanced features. Like maybe we have, just like some of the other caching functionality in Python, be able to look up the cache information on the execution of a Python app. Because Parsl does do some caching, we could perhaps expose it this way. We could build more advanced techniques that, say, require passing two different functions to the constructor of an application. One of the things that is on my back burner for wanting to try out with Bash app isn't having a function that runs after your original Bash app, which reads the files off disk and perhaps cleaned up the file system. You could implement that more cleanly, in my view, if we exposed this initializer for the application through a clear interface, telling the user that there's something very special about this kind of app compared to others. You could also do things like writing a generator-based app. This is something that's probably far future, but you could take a Python function and execute it differently. In short, I think we could do some more focused development on supporting apps beyond just a Python function, or being able to expose capabilities that are otherwise tacitly forbidden to be able to utilize, by providing at least documentation around what the decorator is actually doing and indicating what sort of object it creates as a result. So that wraps up my talk for today. In short, we've talked a little bit about what the Parsl decorator actually, Python app decorator actually is. It's a fancy way for instantiating a app class. I find them great for prototyping, but they cause me to conflate developing my underlying software and figuring out how to deploy it on Parsl, which just worries me, and I don't think it's a good practice. Additionally, decorating inside of your library makes adjusting parameters during runtime at least unsupported or undocumented, if not unsupported and or dangerous. So what I'm hoping to advocate for with this short community talk is making it clear within our documentation that these decorators are one route for being able to create reliable applications to be executed via Parsl. But if you want to do something with perhaps a little bit finer control over the difference between a Python function and a Parsl app, we should make it clear that you can do so. So that's the short of it today. What do you guys think? Anyone find this to be lunacy?
I can chime in. Yeah, want to first thank you for putting this together. What I really like is how you articulated something that I've been doing a long time, but didn't necessarily recognize why I was doing it. And so I share your sentiment that like to model best programming practices and the development cycle, I oftentimes do focus on constructing a function that oftentimes is quite complex, that is as bare bones as possible, not taking anything related to HPC, and then decorating that when I'm done, or not really decorating it, but applying a function to that function. So I share your sentiment, is what I wanted to say first. Um, I personally don't have like major qualms about this approach because I've been using this approach. So, but I have come up with over the last several months of using Parsl situations that are tricky with this kind of thing. And a lot of those have been improved through conversations with the community. Although, of course, there are other things as well. One of which might be, for instance, a conversation I brought up recently about things like keyword arguments that need to go to the underlying function to properly operate, like the Parsl resource specification needs to go into the underlying function. But if you're developing the function independent of Parsl, then it gets a little bit hairy. And these are situations that can be a little bit difficult, although you can maybe use like a partial functools partial kind of thing to maybe address that. Anyway, that's getting a bit in the weeds, but I just wanted to say that I share your sentiment and I'm interested to hear what others think about it going forward as well.
Yeah, so I'll talk a little bit about the comment that Logan made right at the start about if he can't tell whether I was serious or not about calling some of this stuff a novel use case. I think the history of Parsl, because I love my history, the history of Parsl was it evolved from earlier workflow languages where you had a workflow language and you had sort of applications that you were running. And I think at the beginning of Parsl, some of the API design decisions come from imagining that you're writing a workflow just like you did in those other workflow systems, and you just happen to be able to use Python syntax, but you're still sort of writing a workflow. And it's pretty apparent in how people use Parsl now. So like some of the stuff that that everyone is doing really. People are writing Python code and Parsl is just a library that's sitting inside these bigger Python systems, right? So there's a move away from, or there's been a move away from how people use Parsl from I'm going to write my workflow just like I wrote it in VDL or Swift, to I'm writing a Python program that, yeah, I'm going to want to use Parsl, but I also want to do all this other stuff and do all these other software development practices and all the stuff that Logan talked about, right? Is like that way of doing things just doesn't look like how Parsl started out, inheriting its history from workflow systems. So I think it's good to be considering these more modern, maybe, like use cases that are now apparent as being how we should be using Parsl now. That
Yeah, that's a really
we can revisit the API design decisions. Like Parsl, like whether you have parameters on the decorator or whether they're on the function, if you're in a workflow language mode, it doesn't matter. They're just these two places right next to each other, right? It's irrelevant really, and they just sort of arbitrarily put on one or the other.
Mm-hmm.
But more recently, that's not true anymore. So things like that, I think it's good to revisit stuff like that.
Yeah, that's a good point. And that's a really interesting history perspective. Parsl was the first workflow engine I used that wasn't homebrewed. So yeah, that was definitely something I lack, and I can kind of see the reflections now. But I do like
Logan,
oh, sorry, go ahead, Parsl.
no, sorry, go on.
Ahead, you do.
No, Logan, you
But
finish your thought.
I do like the move that Ben referenced of moving towards kind of a more configurable type of application, especially in the context. And I know Ton couldn't make it today because he's defending or doing his PhD candidacy. But he and his team have been doing work around like understanding the context of functions. Like on first execution, this function is slow because it has to import a bunch of libraries and stand up a bunch of like reading and parameter files. That if we had an app where you could denote such sort of setup configuration explicitly, that would be something that I would use. It does, of course, cause me to lock into Parsl a little bit because I'm taking application logic and encoding it in a format that is specific to how it's being executed. But that I would say would be an interesting route to explore.
Right.
Like, what if we let users subclass app? I know it wouldn't work now, or app base, but eventually could that be like a development path forward?
Logan, just wanted to mention a couple of things here. So this is part of this is like stuff that I've been worrying about when trying to do a batch function prototype for compute, because you're essentially trying to bodge together two complete different modes of execution into one execution system. And that's sort of where some of the weirdnesses in the decorator comes from. Like if the decorator only needed to handle Python, we could imagine the Python app could have been simpler. And, again, I want to point at like where some of these weirdnesses really came from, which is Bash applications need to act on files and they will produce files, right? Unlike Python applications where the primary input and output is always assumed to be Python objects, we needed files. And we needed some way to like specify these files because we might need to do some special actions before these functions either execute like on the client side or when you execute it on the remote side. So again, special handling required. So the decorator had to do extra stuff, extra lifting. Then came along the deal that, oh, we needed to have ways to chain things together. So we needed like the applications to be aware of futures being passed as arguments to the function itself, which is, again, if you have a function and you give it params and you give it to a standard executor, it doesn't need to inspect the params, right? It doesn't need to like look at the arguments to understand anything because it's all baked in. But for our applications, we need to inspect. We cannot not inspect because only by inspecting can you understand the dependencies. So special keyword args had to happen, and special keyword args is, I think, what really messes up the app, the decorator versus the non-app mode, because the decorator has to do all of this clunky stuff where it has to inspect all of the arguments. So I've tried to sort of like poke at some of this with the bash functions for compute. I can share like the stuff that is going on there.
Yeah, I'd be curious.
Yeah, so the idea then is that you have this one little package that you construct, and then you can submit that. You have you don't have a decorator. It's just a class. Everything is like open and like presented to you. You can modify those things, and then you give that thing to execute to the executor. In this case, for Parsl, you just give it to the DFK. It's no different from giving it to any other executors. It's just the DFK will do extra things. For example, like the dependency handling. So maybe there is some things to like look at there, because to me it sounds like you seem to have trouble, or you do not like the model where the app sort of hides and does special handling, and you want to be able to have full control over that before you give the function, the constructed app, to execute. Is that fair?
Yeah. Sorry, I was thinking a lot. The first thing I'll note is I did find your MPI app. I forgot what you called it.
I was calling it bash function, MPI function.
Yeah, MPI function. That was one of the things I was pondering on while talking about this. So I'm definitely listening, or definitely curious to see where you're going. The second question, do I not like that the app does special things to my function? I would say no, because I actually think that Parsl is, when it comes to Python functions, very lightweight about the alteration.
Oh, of course, yeah.
I could have a whole nother section on what makes me leery about bash apps, but it's mostly that the community of scientific computing that I work in, materials and chemistry, tends to very rarely or almost always have a Python wrapper that hides the actual system call from you. But that's a whole nother thing. Yeah, so in short, with Python, I actually don't worry too much about Parsl executing or breaking my function or running it in a way that I didn't expect. Because I'm also very diligent about ensuring that that function is pure. And that's not a Parsl thing. Any parallelism needs some kind of stateless function.
Right. Do your functions actually have dependencies in the arguments?
Not very often.
You could actually just throw away the app even, like completely. You could just be submitting.
Oh, just do DFK to submit.
Yeah, nothing stops you from doing that.
Ooh. I might do that. I don't know if we want to showcase that as a route.
Well, at that point, you're starting to look quite like the thing that Logan implemented already, the Parsl
executor.
Oh yeah, that's true.
It's basically that, right?
Yeah.
Yeah, because all the DFK does is dependency management and routing to specific executors, or like not all, but that is most of what it does.
Yeah. Yeah, I've certainly done some sort of, I know I've got some apps that actually do chain execution.
Yeah, Parsl executor should do chaining though. Let me look.
Yeah, I think it would, because it will return an app future.
Right, it still submits to the DFK.
Yeah.
Right.
I know that Yadu hates the DFK and wants it to go away. But
Oh,
Wait. I didn't say that. Let's be clear that I did not say that.
yeah. Um, yeah, I mean the Parsl actually, like, so for context, Logan implemented this other submission system, rival submission system for submitting in tasks that looks at it's not called Parsl executor, it's called something else. What's it called?
Parsl pool executor.
Parsl pool.
To make it
Parsl pool.
sound like thread pool executor.
That's why I couldn't find it.
Yeah, that was mostly to mimic the concurrent dot futures, so that we can
Yeah, right.
target Parsl.
Yeah, I mean that's an okay. So I'm just looking at the code.
What's up, Andrew?
Yeah, I was just kind of thinking a bunch of different things right now, but one thing I wanted to bring up as well is it almost seems like there's also another difference with this style in that based on reading the docs, if someone is going to learn to use Parsl, generally it's assumed that they are having full control over the decorator being applied and they basically own everything in that space. Whereas in what you're doing, and oftentimes what I'm doing as well, is that you're kind of hiding the guts of that from some end user, which the end user could still be you, but could be someone else. And really, you're having that user pass in various keyword and positional arguments to the underlying function that are being applied. But you're taking care of all of the decorating in the internal guts. And I wonder what uniqueness and oddities that brings into things as well. I guess you're also dealing with, for instance, having the user somehow provide some way to specify executors and specify configuration details, which are have to be handled in a certain user-friendly way, rather than just having the user, define everything themselves with pure Parsl. So in another talk one day, it would be interesting to see how you handle all of that user-facing decision making.
Yeah. Yeah, I've only had a few sort of examples of where I've tried to do various levels of hiding that there's a decorator happening, or not a decorator, let's call it a transformation to an app object. Is that language that vibes with the more senior Parsl folks?
Yeah.
Yeah. I've got two examples of where I've tried to hide that through different various shelves or shelves. That could be another interesting talk. And I know QC Engine kind of has Parsl in its own little module. Sorry, I saw Ben Pritchard turned on his video.
Yep.
So yeah, that's at least another example of where there's a library development and then there's sort of like a module that is how to glue this to the execution engine. Place that with welcome, Ben. Good to see you.
Yeah. I don't think I've actually met any of you in person, but yeah, we use Parsl a lot. Yeah, so in the QC archive project, we do use it on the compute side. Since I have taken over the project, we have moved to using Parsl exclusively. But yeah, so we hide this from the user. The user has a kind of a configuration file that more or less maps to a different executors. And it is all, yeah, I couldn't use decorators because it's very dynamic. There's a stage where it's basically like finding out what software exists on that node where you're running and building executors around that.
Mm-hmm.
Or building the Python the apps around that. So yeah, I think the it's basically like the decorators aren't that useful if you are embedding Parsl in something else.
Right.
Yeah.
Yeah. I mean, I think that pretty much from what I've seen of Andrew's stuff is exactly the same thing, I guess Andrew would say. He's got a thumbs up on his image. He's got a thumbs up on his image. So.
Yeah, and it's also this is helpful too because, for instance, I didn't know QC Archive is using Parsl in this way, so it'd be interesting to see how other folks are handling this. Because I'm kind of just going off script, trying to figure out what works and what doesn't work So
Yeah.
yeah, it'll be interesting to see.
Yeah, I see we've got a documentation page for structuring a Parsl program that assumes like Parsl is your main.
Yeah.
I'm
Yeah,
wondering if we need to add
that's that big historical change that I was talking about manifesting itself again. I
yeah.
think
Maybe one of my
would
action
be-
items after this could be like to sketch out a page of using Parsl with established libraries. And we could
Yeah.
talk about the application patterns we tend to use. Either you've got a main function that handles all the Parsl integration, or as QC archive and Quack
Yeah.
do it, have some more like glue type examples that help map between the different application. And I've got a few like short Parsl. I typically, every one of my libraries has a run function in sandbox glue code that we can provide, and then maybe eventually mainline, though I know Bash app has Yadu's attention. It might eventually include sandboxing, so.
Sandboxes are included, Logan. I will share code with you. Yes.
Perfect. I do like
Yeah.
a sandbox. And I can cut like 100 lines out of various libraries I have.
Mhm.
But yeah, what do you guys think about? I can take a stab at a using Parsl with existing libraries, and I can put it in my view, and then we can gradually collect like the Andrew and the Ben.